Hi everyone, welcome to another video on way to programming. And in today's video, we're diving into an advanced callback technique called memoization, or it's also called caching, right? Uh, Memoization or caching. And this technique is actually used to improve the performance of different functions in programming or in your computer. And it does that because I hope you are aware of caching technique. So it's the similar, it is somewhat similar, and it improves the performance of your functions by storing and reusing previously calculated results. So that way you can speed up computer programs. And if you're familiar with caching, you would know that that's what it does. Caching is used to cache frequently used data so that next time the time it takes to fetch this data is less. Similarly, memoization is a technique that involves caching the results of expensive function calls and then returning the cached result when the same inputs occur again. Now, you may ask, what is an expensive function? So, expensive function call means calling functions of complex nature. Now, how are they made complex? Well, a number of reasons. It could be that you are using complex algorithms or heavy computations in these functions. And if these functions have repetitive computations or recursive algorithms, caching or memoization can be beneficial, right? Because if you have to repeat the same complex operation or computation over and over, it can be expensive, you know, in terms of processing. So memoization and or caching is useful there. And to help you explain the concept, now I'm going to create a very simple function, right? So let's start by creating a function, and it's going to be a basic memoization function, and we'll use a dictionary to cache the results of function calls. Okay, and I will first define a memoization decorator with a specific name, and then this can be applied to any function, right? So again, the logic will be that the decorator will use a cache to store and retrieve the results of function calls, so that redundant calculations for same arguments can be prevented. And then the decorator will be applied to Fibonacci function, and you'll see that the result for this function for a specific number is only computed once and then retrieved from the cache on subsequent calls. So let's first define a function called memoize that takes another function called so let me define uh, okay, so let's suppose this is the name of the function, memoize, and it takes another function, and that function name is func, right? So it is taking that function as an argument, and okay, sorry for that. Now I'm going to define this function, and I will do that by creating an empty dictionary, and I'm going to call it cache, right? So that it's easy to remember, and it will store the results of function calls, right? After that, what I'm going to do, I'm going to define a nested function, and I'm going to call it wrapper function that takes any number of arguments, right? So since I want that this function should be able to take, any number of arguments, I'm going to call it uh, wrapper function, right? And it should be able to take any number of arguments. So I'm gonna use star args for it. And because it is going to take many number of arguments, I also need to check if the arguments are already in the cache, right? So for that, I'm gonna use conditional. So if args not in cache, if it is not in cache, I will call the original function func with the provided arguments. So it will be result equals to func star args, right? And then I need to store the result in the cache dictionary with the current arguments as the key. So it will be cache args equals to result, right? And then I can maybe print a message indicating that the result is being cached. So I can just write um, print caching result for whatever function we have, and I'm gonna go with name curly bracket aux, and we're gonna have result here, right? And then we can return the result from the cache, right? So return cache. All right. Now we need to return the wrapper function, which now includes memoization. So uh, outside, when we come outside, we're going to return wrapper, right? Now we need to decorate the Fibonacci function with the memoize decorator. And how do we do that? I hope you remember we use at the rate symbol, and then I'm going to write at the rate memoize, right? Now I need to define the Fibonacci function, which calculates the Fibonacci sequence. So for that, I'm going to create a different function. I'm going to name it Fibonacci, and then Fibonacci or Fibonacci people, I mean, like, call whatever you want to call it. It's programming anyway. Um, so so this is like going to be Fibonacci. Actually, I teach business English also, right? Uh, so when I'm teaching big business English, that time, I have to be, wary of a lot of things, the grammar part of English and the vocabulary, the pronunciation, and all that. But in programming, just go with whatever. Logic should be right. Okay. So anyway, I'm going to define this function. So again, when you're working with, it's going to be a recursive function. And when we are working with recursive functions, we need a base case and we need a recursive case. So first, I'm going to write a base case for the value of n if it is 0 or 1, right? So if it is 0 or 1, we for Fibonacci functions, we return the value itself, right? So if let's say n is less than or equal to 1, I'm going to return the number itself, that is n, right? And then I'm going to create, so this is base case. Now I need to create recursive case, right? In recursive case, we will return the sum of the two previous Fibonacci numbers, right? Uh, if you don't know what I'm talking about, you can go to that specific video where I'm explaining Fibonacci function, how we create it, how we work with it. And so here I'm going to return n minus 1. So we need two values always. This will be n minus 2, right? And now we need to call the Fibonacci function with specific argument, right? So let's say I call it with an argument 5, right? Just to be on the safe side. And I also want to print this value. So I'm going to use print function also here. Um, right? And now I will call this function again with the same argument. And this time the result should be retrieved from the cache, right? So I'm going to call it one more time. Actually, you don't have to write these two statements here. You can write it when you're actually running the function also. But let me save it. I will call it something easier and let me run it, right? So if you see the result also, uh, for specifically for redundant calculations, memoization is very useful. It will avoid the redundant calculations. And if there are overlapping sub problems, like again recursive algorithms or repeated calls with same inputs, like this call will be repeated because there is same input, right? 5. So for these, it's going to be beneficial, right? So for this function, you will see that for the first invocation, because we are invoking the function for 5, for the first invocation, you'll see that the result has been cached and calculated. But when we run it for the second time, right, for the next invocations, when second time we are doing it, you won't see the message, right? First time for the first invocation, you are seeing the messages. But when we call the function one more time, when we call this function again, you won't see this message. You will just see the value, and that is because the function has already cached all the values, right? So the values have been cached, and it saves time because it will not repeat the same computations or the calculations, right? So that's benefit of memoization. And yeah, if you have any doubt, feel free to ask. And I'll see you in the next video. Till then, take care.